Let's answer all of these questions. Yes, negative exponents exist. No, that does not necessarily mean that the entire term is negative. Again, that negative is up on the exponent line, the superscript line of it. It's denoting that the exponent is negative, not the base. What does it mean to have something multiplied by itself negative 3 times? Here's where we get into semantics, We come up with a bona fide definition of repeated multiplication. Then, through clear steps referring back to the definition every single time, we've kind of created a brand new concept of a negative exponent. Well, let's get to the bottom of this. Let's see what the negative exponent even means. We can see that these are all equal to each other. We started with something that our definition was able to handle. Then we got to something that I guess we can understand. Fractions and exponents together forever. This is the different thing. And this is... Whoa, that was my elbow. Based on all of this, let's see if we can make a consistent definition or property or something that includes negative exponents now. It seems to me that when we have a negative exponent, it means that it is reciprocated. We flip, this is on the baseline, or at least it's in the numerator of the baseline, and then we reciprocate it as 1 over x to the third. Even though it goes from bottom to top, gaining a negative or losing the negative, whichever way you go, note that the 3 stays with that base, that variable. That's important because that exponent isn't going to randomly move. Like, we have to do exponents before we resolve this division. So, of course, the exponent has to stay with the base that it was attached to before. I know that was a lot. Let's see if we can just kind of formalize it like I said I would, and then I got off track. If we have x to the negative first power, it's the same thing as 1 over x. It's the same thing as reciprocating the base, keeping the exponent. Now, if we have x to the first power, that's just x. But we can kind of say this in general, that x to the negative nth power, where n is any number, that's the same thing as 1 over x to the n. I'm not sure if I can relate this exactly to the definition of an exponent, because the definition kind of assumes that it's on the baseline. So I think that this is going to be a new definition that we're going to kind of add. All of these shortcuts and properties are going to get so jumbled up because we're going to be assuming other properties to kind of prove them, other shortcuts to prove them, and there's just going to be so many of them, we don't know what, we might not be able to prove what's true and what's not true at that moment, but we can always untangle all of them and then eventually get back to that original definition. And we can't go weaker than a definition because a definition is kind of like a starting place. We start with a definition and then we kind of prove things based off of that. I don't know if that's going to make the cut. Okay, something that I should go out of my way and mention is that the reciprocal of this rule works. So if we have 1 over x to the negative first power, the negative exponent here is going to actually send the base up to the top. So then we just get regular old x.